profile file, right?
Yeah.
After that, you have given something like source dot bash underscore profile. Is that to refresh that file, or why
Yes,
you?
it is to refresh that file. So
Okay.
whatever change we did,
Mm,
whenever you change that bash profile file, right?
mm.
So those changes are not effective unless and until you log off and log in back.
Okay.
So that file is refreshed every time you log in.
Okay.
So in middle means without log off and log in, you want to refresh that source command you need to use. It is a Linux thing, nothing to do with Postgres.
Yeah, yeah, I got it. I got it.
Okay.
Okay. Okay.
So that is what, generally the bash profile is refreshed. So when you log in,
Okay.
okay. So the bash profile is refreshed when you log in. So in between, without logging off and login, you want to refresh while within the session. Okay, you need to what we say means source it. Any other questions?
No, thank you. Thank you, sir.
Okay,
Sami,
so yes,
regarding that cluster initialization and stop start services. So stop start services we have done from root user or admin user, right? So from
yeah,
Postgres user,
root
can we
user.
do this?
Yeah, yesterday the systemctl command we learned, right?
Yes.
Systemctl command is a Linux command. It is
Yes.
not a Postgres command.
Hmm.
So that is to start, stop, manage any service which is running in Linux.
Correct.
So that is from Linux, provided by Linux.
Hmm.
Apart from that, Postgres also provides one command to manage the service. Same start, stop, restart. So Postgres also provides one command. So today we will see that command also.
Okay. And initialized that one, I mean cluster initialize. That
Cluster
is,
initialization, that is one-time activity in life of a server.
and that
So,
should be from admin user, or that can be only possible from Postgres user.
that is also possible from Postgres user. So cluster initialization is a one once in lifetime activity. So for one server, right? So you will initialize only once. Once the server is initialized, that's it. It will be running only on the newly installed server, newly set up cluster. You do initialization. So
Okay.
you don't do initialization once again, okay, on the same server.
Okay. Okay. That means if we have any patching activity or anything, if we stop services, we need to only start, right? Initialize
Yeah,
is not
only
required.
start. The
Okay.
initialization again is not needed.
Got it.
So
Got it. Now
only
got it.
yesterday I have stopped and stopped two times, right?
Hmm, 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 hmm.
Right. So I
Yes.
didn't
Yes.
initialize. I didn't initialize.
Yeah. Correct.
Okay. Any
Oh,
other questions?
no. Thank you, Sami.
You're welcome. So, anyways, what we are going to learn today is so somebody is absent today. Anyways, once what we
Uh,
are going to learn today is okay, just a minute. Okay. So today we are going to learn two things. One is today we are going to learn about architecture. It is a complete theory session. Maybe it may take 1.5 hours or 2 hours. So it will take, and sometimes it may also take more time. So there is no worry about the time. We have plenty of time. Okay. So that is one thing. Architecture is a most important lesson you guys knows very well. So you need to understand the architecture. So compared to Oracle, Postgres is a very small database, right? It is a baby database. If you are an expert in Oracle, so and you come to the Postgres, you don't treat Postgres as Oracle database because it's a baby database. It's a small database. So So that is what, always you have to keep in mind. I'm dealing with a much simpler and smaller database. Okay. So the architecture lesson. So architecture lesson, so will give us understanding about, so architecture lesson gives us understanding about, how the Postgres works. What are the various components of the Postgres we have? So we will come to know about all these things. So in this lesson. So pay attention and, don't hesitate to ask questions. So this is the topic. So you are free to ask questions. So also, what I request you, after every topic, so I will give some time so that, you can, what we say means, ask questions of, related to the topic. So that is what my request is. So let's get started with our,
Sami, one more question.
yeah, go ahead.
Uh, Sami, like yesterday when we were after installation, we have set up the DB init.db, like we have initialized, right? Like that setup, right?
Yes.
From that user profile and etc. In that the same folder, there are many other files actually.
During the course of the period, so you will come to know about many of those.
Okay. Then fine. Then fine. It's fine.
Okay.
Thank you.
So you just want to know about each of that file?
No, I was just asking like what it relates, like whether we can, do we need to run or set up any other files to
No,
and
not
know
needed.
about more,
Not
know
needed.
more about that
Those
files.
files are,
That's all I was.
so those files are, your storage. System data is there in that. Your, what we say means, your, till now you didn't created your tables, right?
Correct.
So if you create your tables, that tables will also be there.
Yeah,
Okay.
that's what create database, create user, like create tables. A lot of things was there. So I was just thinking like whether that need to be ran or what.
No, not needed. So, so let's start. Just give me a minute. So you guys are able to see the screen, right?
Yes, we are able to see.
Okay. So when we are learning this architecture lesson, so we will see some of the things which are similar to Oracle database, maybe different than DB2 or some other database. So some few things are similar to, at least I can say, SQL Server. So as I can say, yesterday we have discussed about the history. So Postgres has a very long history. And because this database is developed in a university, so based on it, other databases also developed. Okay. So the Sybase database and Informix database were based on the Postgres. And from Sybase, SQL Server database is based. So, basically the SQL Server database originally got its ideas from the Postgres database. It is, mother to the SQL Server and, Sybase databases also. It is a very old database. It is the second database which is developed after Oracle database. And it was in university. That's the reason, so this database, was understood by many students who later on become programmers, uh, so to develop other databases. So that is the reason, so it shares traits with many databases. It shared traits with, SQL Server. It shared traits with Sybase. So it shared trait with Informix and Oracle. So, all databases. So it has something in common. Okay. So we will see how it works. Okay. So the other thing is, the SQL Server or DB2 or, Oracle, there are all very, very, what we say means big databases. Particularly Oracle has a lot of features. So SQL Server and also has a lot of features. I'm not sure about DB2, but DB2 is used by big enterprises and definitely it will also have a lot of features. So, but Postgres is a very small and simple database. Yesterday we have seen post installation, the size of the installation, including the tools and everything, libraries, tools and everything is 36 MB. Out of this, the core server is just 7 MB file. The core Postgres server is just 7 MB, 7 or 8 MB file. Okay. So that much small database it is. It's like a big database for you. It means baby database for you guys. So who had a lot of experience on other databases. Okay. So, but it has its own strengths. It has its own limitations. Okay. So our focus here is to see what are the strengths or how it works, right? So that is what our focus is, how Postgres works. What are various components of Postgres? So here we have PostgreSQL uses processes, not threads. So in database programming, anybody who wants to create a new database, so they have two options to choose. Either write a database or develop a database which is process based, or develop a database which is thread based. Okay, so this is not a forum to discuss which is good and which is bad, what is the strength of this one, what is the weakness of that this one. So it is not the forum, because we cannot do anything. So we have to use this product, right? So the processes are, everything is a process which is visible to the operating system. For example, in Oracle database, if a new connection comes, if a new connection request comes and the session is granted, you can see that session from the operating system, right? So you can, from the PS command, so of operating system or task manager, you can see the user connections, right? So every user connection is a process which is managed by operating system. Okay. So that is what, the process based databases are. Everything is a process there. And these processes are visible to the operating system. Okay. So the Postgres creates that process and hands over it to, or requests the operating system to create that process. And the operating system will take care of that process. Okay. So in thread-based databases, so if a user is connected, a session is granted, so the details of that session are not visible to the operating system. Operating system don't know about the user session. That does not appear as a process from our operating system. So the database itself will manage the user session, internal processes, all of that database will manage, and the operating system just sees one process, that is the database executable file. So only one process is visible to the operating system in thread base, and every user connection, every internal processes, like, so the check pointer, background writer, they are all internally managed by the database. So that is thread based system. So we have successful process based databases, like Oracle is a process based database. So Postgres is other process-based database. We also have successful thread-based databases. Like MySQL is a thread-based database, and SQL Server also is a thread-based database. Both of them are very highly successful. So so either it is a thread based or process based. So, so it is none of our business to go into any of the what we say advantages and disadvantages. But we have highly successful process based databases, highly successful thread based databases we have, and Postgres is process based. So Postgres is what? Process based. Process based. So like, if a new connection comes, you can see that connection from the operating system. And if you want, you can use the operating system kill command to terminate that session also. Same thing like you do in Oracle. Okay. DB2, how it is process based or the thread based?
It's thread based. Only
Thread
one
based, right?
process you can see from operating system. Yes.
Okay. Here, multiple processes you can see. A lot of some processes are dedicated to the Postgres only, and user processes also you see. So, the process based are, Oracle is process based and Postgres is also process based. Okay. Thread based, if you go, you have SQL Server, DB2, MySQL. So, these are, examples of thread based databases. And these are the examples of process-based databases. So every approach has its advantages and disadvantages. That is not the focus. So Postgres is process-based. So it is some resemblance or similarity with Oracle database. Postmaster process acts as supervisor. Now, so when we are talking about the processes, let us go to the lab machine and check. Here I am in the lab. So who am I? So I am Postgres user. So what I will do is here I will run the ps command, ps hyphen ef. So grep Postgres. Okay. So there is one process you can see here. The first process. So you can see this first process. The process ID is, 16. The process ID is, 16. So 075, that is the PID. So the parent process ID is 1 because, it is a service. It is initiated by, so it is a service which is initiated by. So it is the service which is initiated by the systemctl command, right? So that's the reason, the parent process ID is 1. So, it is postmaster. So it is also telling you from where it is running. So you are having the USR. So I think you are familiar with this path, right? So you are familiar with this path, right? So this is where our executable files or installed files are. So there is a thing called as postmaster there. So postmaster process. I think you are also familiar with this path as well. Okay. So this path as well, you are familiar with. So, the mouse pointers and all generally doesn't work very well. So, forget about it. You can see this path, right? Where live PGSQL 14 data, this path also you are pretty much familiar now. So this is the postmaster process, and this is the supervisor process. It is called as supervisor process. Okay. So the current PID of postmaster process is 16075. Then you have other sub processes like logger. Logger is for alert logs, the error logs. System wide warning messages, error messages are captured by it and they are written to a file. Okay. So, so logger process, you have checkpointer process. Checkpointing means, every what we say means, so every interval, fixed interval, Postgres performs the checkpoints. So these are the same checkpoints like other databases we have. So checkpoints are performed at a regular interval. So that is one process which will be sleeping all the time until and unless the time for the checkpointing comes, it will wake up and it will do the checkpoint and it will go to the sleep. Whereas logger process is always in wakeful state, and it always looks for any warnings or messages from the system, errors from the system, and it will write those messages into a file, that is log file, and it contains a very good amount of diagnostic information. The second thing is background writer. The background writer process is, it is also a sleeping process. So it has a sleep interval and a wake interval. So it will sleep and then wake up and it will find what are all the dirty pages are. So it will clean those pages. Okay. So from the shared buffer. Val writer process. So its responsibility is to write the val to the disk. The val is redo log. Okay, that's very simple. We call it as val here, write ahead log. So write ahead log. So because the original book term for the redo log is val only. So the industry term is redo. So, but the book term or the academic term is write ahead log. So because any transaction you do before it is written to the data file, it is written to the redo log. So that's the reason write ahead log, ahead of the data file. It is written ahead of data file. So that is val. Writer is responsible for writing that. So you have auto vacuum launcher process. So there is a vacuum thing which is different. You don't find in any other database. It is specific to Postgres. Vacuuming is very specific to Postgres. I at least the databases I know like Oracle SQL Server, MySQL. Okay, to some extent Sybase, they don't have this vacuuming. Okay, the vacuum process, auto vacuum process is the one which does the vacuuming. That vacuuming is, actually literally vacuuming here. So that is cleaning up. So, that is a cleanup process. So then you have the stats collector process, you can see. So that stat collector process is responsible for, the statistics. Okay, generally, so in Postgres, we have two kinds of statistics. So one thing difference here is Postgres has two types of statistics. What is the purpose of the statistics in database? Anybody can tell? So Postgres has two types of statistics. One is usage statistics. So these are useful for monitoring and diagnostic purposes. For monitoring, okay, and diagnostics. So that is the purpose of this. So, usage statistics. Monitoring means what is happening on the server. So the usage statistics will help you with that. So, so usage statistics will tell you what activity is happening on the server. So that is usage statistics. The other statistic what we have is optimizer statistics. Okay, these optimizer statistics offer so query plans. Okay, so these are the two types of statistics we have in Postgres: the usage statistics and the optimizer statistics. Okay, so the usage statistics are collected by stats collector process. So whatever the you are seeing here, stats collector. So this is going to collect the usage statistics. So this guy is going to collect the usage statistics. Okay, not the optimizer statistics. Okay, so optimizer statistics are used by, the query plans, used in query plans by planner and optimizer. So that is a different kind of statistics in Postgres. The usage statistics are, what is the user activity means, what is the activity on the objects, not user activity, but, the activities on the objects. So that is, monitored. So, that is what the usage statistics is. The usage statistics is, uh, collected by the stats collector process. This is the one which is responsible for collecting the usage statistics. Okay. And, you have few other processes like, you have this logical replication. Okay. So logical replication process is there. So that is useful when we go for logical replication. Right now, that process is sleeping. So it is not doing anything. So it is running, but it is actually sleeping. So you can observe one thing here. The process ID of postmaster process is so 160, so 16075. That is the process ID of postmaster process. I cannot disable this. Okay, 1605. And the parent process ID of, all other processes also 16075. You can check out, right? So all other processes also have 16075. They have their own process ID, like, 16077, 16079. So they all have their own process IDs, but parent process ID is the process ID of postmaster. So that's the reason postmaster is called as, that's the reason, the postmaster is called as supervisor process. Okay, it starts first when you start the Postgres service. postmaster process starts first, and then it will start other processes like stats collector, okay, logger, checkpointer, background writer. So all other processes are started by the postmaster. So first it will start, and then others it will start others. Several utility processes, the checkpointer, logger, background writer, these processes are called as utility processes. So because Postgres needs them. So Postgres needs stats collector to collect the usage statistics. Postgres needs checkpointer process to perform the checkpoints. Postgres needs, so the logger process to collect the system-wide error messages, warning messages, and other kind of messages. Okay. So these are the processes. These processes are called as utility processes because they help the postmaster in running the Postgres server efficiently. Okay. So that is what the utility processes are. So postmaster is the supervisor process and others are utility processes. Postmaster starts them, restarts them if they die. If any one of the utility processes gets killed due to some reason, postmaster detects that and automatically it will restart that process. There is no intervention of DBA needed to restart them. So any process dies, postmaster will automatically start them. So there is no need for you to worry about the utility processes. As long as the Postgres service is running, the utility processes are also guaranteed to run. Nobody can stop them. If somebody kills them, so postmaster will automatically restart them. Okay. So even the end user will not feel any, what we say means, any, okay, any issue or any, what we say means, disturbance to the session. So end users will not see any disturbance to the session if somebody kills a utility process. So immediately postmaster will start that utility process back. One backend process per user session. Every user session will have one backend process like Oracle database. So we will call it as backend, or the backend process or user session. So every user session will have. So for example, if I go here, so I will click here and I will duplicate this session. Log in as Postgres. I can directly log in as Postgres now because we set up the password for Postgres user, right? Okay, I have logged in as Postgres. So I'm doing a PSQL. So I am connected. Okay. Now I will come back here to my first session. So here, so you can see right now, there is no user session you can see right now. So I will run this ps-grep command. So you can see this one. Okay. So this extra session has come. And this is what, the user session is. Okay. So it is, there are a few things. It is saying Postgres, Postgres, Postgres. So I will do one thing here. So, exit from here. I will reconnect here. What is template one? I will show you later on. So that is not very, very important. So now you can see. So my user session has slightly changed. Okay, I will do something else here. So Postgres provides the sleep function. Many databases provide the sleep function, right? So it is PG sleep. So this function will run for, given number of seconds. So I'm giving it, 120 seconds, 2 minutes, run for 2 minutes. Okay. There is no need of dual. There is no dual table in Postgres. So whenever you are running the functions, you have to simply say select and function. There is no need to say from dual like Oracle. So it will run for 2 minutes. So I will, in the meantime, I will go and check here. So you can see, I am running the select, it is showing me. So what I am running. So that is what the user, okay, process is. So that is how it appears here. Okay, that is how it appears here. Every user session, so is a process. So if I kill this, so my process will be, my session will be disconnected. Okay, so my session will be disconnected. Okay, so simply I can say kill. So okay, so that is how I can kill it. Okay, okay, it can say. So server closed the connection unexpectedly. This probably means server terminated abnormally. So, it is telling a lot of things to us. So you exit from here. So Postgres, the server is killed, but the PSQL still hangs on. Okay. It will still hangs on. Okay. So that is what very simple. You can kill any connection. You can use the ps-ef command. So, and you can kill, this is the basic things you can do. So as a DBA, so you can kill others, right? Shall we kill a utility process? I told you, yeah, that if you kill the utility process, nothing is going to happen. It is going to restart again, right? Right.
Yes.
So it's time to test it. Shall we? So which utility process you want to kill? For example, very critical, wall writer. How about this one? Okay, now it is, you remember 109482. So 109482. So I have killed it. So again, I will check it. Again, I will check 109482, right? So 109482. So wall writer process has come up. Now the number is different, 109646, not 482. Okay. So in the meantime, it has, killed that process, and I have killed the process, and the postmaster has restarted the process, right? So now you are very much, what we say, assured that, so, killing a utility process actually does not harm anything. So it does not do any harm. Okay. However, don't kill the postmaster process. So, it might harm. So killing a postmaster process might do harm, but not the utility processes. Got the point? So one backend process per user session. Postmaster listens for new connection. It is also like a listener process. It will also do the duties of a listener process. We don't have a separate listener process here. The postmaster is a supervisor and also it is listener. Okay. So this process listens for the new connections. And Postgres uses only one protocol, that is TCP/IP, for the wired communication. So it will use TCP/IP. Okay, so that is what it uses, and port is 5432. So that is about few points about the Postgres. Process and memory architecture. How Postgres uses the processes. Already we got about the processes, we got some idea. Actually, in fact, very good idea. So how it uses the memory and for what purpose it will use the disk. So these are the things we will see next. So this is somewhat, the Postgres architecture diagram provided by EDB. So, and the second quadrant, these are the two companies which provided this diagram, because the Postgres is open source. So for many years, there is no proper documentation for Postgres. So the Berkeley people, they put up that Postgres for free use, but they didn't publish any much document regarding the Postgres. Not much document was available. And people who started early, like, I started Postgres in 2007 or 8, late 2007 and early, I got a project at that time. So, in the third quarter of, our 2007. And, actually the project started on 2008. So, from that point of time, I'm familiar with this. I'm working on this Postgres. Okay. So 2008, at the time, the first version of Postgres I used somehow was 7.x version. So it was a very different version. So there is no comparison with today's Postgres with that one. Okay, you don't have triggers there back then. You don't have the programming back then. Okay, so you have a lot of limitation back then. Okay, so that was the problem at the time. But somehow the documentation was very less. Even though, but by the time Postgres was open source, but there are not many takers for Postgres. So architecture and all, you don't find any diagram, you don't find an architecture diagram, you don't find details about the architecture. So that was, lack of documentation. People really struggled who started early on Postgres. So anyhow, after second quadrant and EDB so started contributing to the development of Postgres, they did a lot of good work and they put up very good document, especially the second quadrant people. Now it is part of EDB. So they put up a very good documentation. So one of the documentation, part of the documentation, this diagram is part of the documentation. So Postgres memory architecture. So the Postgres has a shared memory. So generally a Postgres has a shared memory. Generally every process, every user session is allocated some of its own memory. So some of its own memory, but there is a thing called as shared memory, which is shared by all processes. The user processes, utility processes, all processes will use this shared memory. The shared memory has three parts, three allocations, three different allocations in the shared memory. So one is called as shared buffers, other is val buffers, and third one is process array. The shared buffer, the shared buffer is so a central or the most important memory allocations in the Postgres. The shared buffer is responsible for any database changes. So if you are doing an update statement and you need to what we say means do the change, so that the data is fetched from the data file into the shared buffer and then it is changed. The shared buffer is also called as buffer or shared buffer in other databases, or buffer pool in other many databases. Like in SQL Server and MySQL, it is called as buffer pool. So I think in Oracle, it is called as shared buffer only. Okay. So here also it is called as shared buffer. Okay. This is the place where the majority of the activity happens. Any update, any insert first goes into the shared buffer. Then, the action is taken in the shared buffer. So later on, okay, the changes are written back to the data files. The changes are done in the shared buffer first, and later on, those changes are written to the data files. Okay, so that is the shared buffer, and it is always recommended to have a large shared buffer. It is always recommended to have a large shared buffer. Okay, so that is the thing. And then, the other important memory allocation in the shared memory is wall buffer. So wall buffer is, for a ongoing transaction, for an open transaction. So the transactional entries are written in the val buffer. So the transactional entries are written in the val buffer. And later on, okay, when the user commits the transaction, so those entries are written to the physical val files. Okay. So for an open transaction, the entries are written in the val buffer first, and when the user commits, so those entries from the val buffer are written to the data val files, and user is sent a success message. Your transaction will show you a success message only if it is able to write it to the val files, physical val files. Okay, so that is the purpose of the val buffer. And process array is the third memory allocation in the shared memory. So process array. Process array is used by, PostgreSQL for storing statuses, a lot of other things it will store. And the process as a DBA, so you can see or control how much shared buffer can be allocated, how much wall buffer can be allocated. You can control only these two. You cannot control how much the process array to be allocated. So that control you don't have. Means there is no option within Postgres where you can set the size for process array. But you can set the size for val buffers. You can set the size for shared buffers. Okay. So these are the three memory allocations we have for, for shared memory. Okay, shared buffers where actually all the data changes occurs, and then those data changes are written to the data files. Val buffers, the ongoing transactional entries are written to the val buffers, and when the user commits the transaction, the val buffer entries are written to the val files, physical val files on disk. Process array is used for many purposes by Postgres. So for storing the statuses, a lot of things it will store in that. Okay, so these are the three memory areas, out of which as a DBA, you can decide the size of shared buffers and wall buffers. The size of wall buffers and shared buffers can be decided by a DBA, can be set by DBA. Okay. So then, you have the background writer, check pointer. So in the yellow color here, you are looking at, various processes. Already we have seen those processes, right? So, archiver is that, archiver process we didn't saw because we didn't enable the archiving yet. When you enable archiving, you will get that archiver process also. That is also a utility process. Okay. The other processes we are able to note: background writer, check pointer, auto vacuum, wall writer, stats collector. Okay, log writer, that is logger. So these processes, These 6 processes we are able to identify. So archiver process, when we go to the topic of, backup and recovery topic, so then we will discuss about archiving. So we will set up archiving. So you will see that archive process. So that is what, the processes are. Okay. So data, what it saves in the disk, what Postgres saves on the disk. Generally databases, out of all the applications you have in the world, database is the only application which saves a lot of data on the disk. Data files. Okay. So your table data files, wall segments, that is physical wall files. So physical wall files on the disk, they are called as wall segments. That is the official term. Wall segment. That is nothing but the wall file or redo log file. So in the common man's language, it is redo log file. So the wall segment files, archived walls. Archived walls means, if you enable archiving, so, the redo log files are, saved, archived, right? So that is archived walls. Error log file, usage statistics are also saved on the disk. I said, there are two kinds of statistics. So usage statistics and, the optimizer statistics, the both of them are saved on the disk basically. Okay. And status files, a lot of status files are maintained by Postgres. So they are also saved on the disk. So these are the things which get saved on the disk. Any questions here? So we have,
Swami,
yeah,
that auto vacuum, that one, what actually it will do? It will vacuum data from buffer like that.
no, not for buffer, from disk. So we will see now in within few moments or within this session,
Okay.
you will see the use of
Okay.
AutoVac. Okay. Now, postmaster process, we will see some more details about the postmaster. It is a master process. It is the supervisor process, master process. Okay. It is also called as Postgres. So you can call it as postmaster or Postgres. Why? So I will show you a reason for that. CD, USR, PGSQL, in. So this is the directory where all executables are there, right? Agree? So you have all these. So, there is a postmaster also here. You can see. And there is a Postgres also, you can see. Okay, sorry. There is a Postgres also, you can see. Right? So let me do one thing. ls-l. So what this postmaster file is actually, anybody can tell? It is starting with L right here.
It's a
So
soft
the
link.
link, it is a soft link, which is pointing to
Postgres.
Postgres. So, both this file is nothing actually here. So earlier, in older versions, we don't have the Postgres file. So we have only Postmaster in older versions, but later on they changed it. So I don't know why they changed it, but they changed it. So, the Postgres and Postmaster. So, Postmaster is nothing but it is a pointer to Postgres. Actually, it is the Postgres is the actual server. What is the size of Postgres file? It is just 8 MB file. That is your complete Postgres server. And all these, what you have, other files are, they are tools like, you have PSQL tool. So PSQL tool is there. So that is what our client is. It is like SQL plus. So you have the reindex. So it is the tool to reindex. Okay. So, all others are, the tools to, manage the database. Okay. But, the database server itself is Postgres, whose size is so 8 MB. So 8 MB we are talking about, you compare to other databases and their sizes, so you will come to know. So how small this database is. So that's the reason I told you that it's a baby database. So for those who are from Oracle or SQL Server, it is like a baby database. Manages utility processes. We have seen them start. We have, did the experiment also. Listens on one and only TCP port. Default is 5432. You are free to change it. So tomorrow when we learn the configuration lesson, so we will see how to change the port and other stuff. So, by default, it is 5432. So, but, you can make it listen on another port, but again, it's only one TCP port. That's it. Only one TCP port. It won't listen on another TCP port. Like, in SQL Server, you can create endpoints. You can create in Oracle also, you can create that endpoints, right? So, we cannot do yet. So till for 15 version, you cannot do. Maybe so in coming versions, they may also add that, but till now, you cannot do. Receives client connection request. It is a listener process also. So that is about, the postmaster process. Now utility processes, background writer, what it does is, so writes the updated data blocks to the disk. So from the shared buffer, whatever updated or dirty data blocks are there, so they are written to the disk. Okay. So that, the new transactions can always have fresh blocks. So, wall writer. Wall writer, as I told, whenever the transaction commits, it will write that transaction, means it will flush the wall buffer to the disk. So check pointer process automatically performs the check pointer, by basically it is a 5 minutes default time for checkpoint interval is 5 minutes. A DBA can change it. So DBA can change the checkpointing time. Auto vacuum launcher starts auto vacuum workers as needed. So, we will see about the auto vacuum in this session. So auto vacuum worker, the launcher does not perform the vacuuming. It is the workers who perform. The launcher is like a scheduler, it will be running in the background. Okay. And there is a frequency, there is an interval. Every that interval, it will launches workers and the workers will do the vacuuming. So that is once the worker completes the vacuum, so it will be removed. The worker process is so completed and it is removed. But the auto vacuum launcher will remain in the background, so waiting for the next turn. Logging collector, that is, the logger process. Okay, that is collects system wide error messages and all. So, in Postgres data directory, where is my data directory? So where is my cluster data directory? Anybody can tell?
Cluster.
Where lib PG SQL.
This is my cluster data directory, right? So in that, so many files and so many, the blue color ones are directories and the white color ones are files. So many of them are there. So, some of them you can easily identify what is the purpose of them. So there is one thing called as, log here. So you go to the log. So you go to the log. So in the log, so you have these two log files. Okay. So every day, it is a default is every day it will create a new log file, and for 7 days it will maintain the files. Yesterday we have initialized this cluster, right? Yesterday we have initialized this cluster. So yesterday it created the Monday log file. Today is the second day. So it has created Tuesday. Tomorrow, Wednesday file it will create. Okay. So this behavior you can change, but so if you want to, you can change. For 7 days it will do. On the next Monday, it will override the that Monday file. So on Monday, next Monday, it will overwrite that Monday file. Okay. Always you have last 6 days, okay, of log file and today's log file. So that is what, system wide error messages, everything will be there. You can use the less command, cat command, to see what is there in that file. It is a plain text file. Oh yeah, it has captured our activity. Server process terminated. Okay, not that, ours was something different. 462 something it was. Okay. So we will check about, the Monday. Okay, so if anything, any errors or anything has occurring on the server, so it will record that. I think I should do an error and I should demonstrate. So PSQL, so I have logged in. So I will do one command. So select star from EMP. So the table is not there, it is an error message, right? So the relation EMP does not exist. So it tells you in the book language, academic language. It won't tell you table not found in the industry language. So it tells you relation EMP does not form, does not exist. So very nice way, So that is an error. So it would have captured that error. Generally, it will capture the errors. Okay, you can see this error is captured here. Okay, so this is captured here. So, so this is the log. You have to go and you can check and you will find out. So if any errors or any warnings are coming up, so or any panic messages are coming. So, the severity, highest severity is panic. So panic messages are coming, error messages are coming. So you can see the messages from warning messages onwards, you can see. So warning messages onwards, you can see warnings, errors, panic messages. So, you can see in that log file. So in the data directory, a log file is in. So what we say means this file. Okay. Installation directory. So we have already seen installation directory. So USR bin directory, USR PGSQL. So if you install 13 version, it will go into the 13 version. If you install 15 version, it go into the 15 version. If you want, you can do that installation also. So bin, lib, and shared, these three directories we have. So the bin directory contains all executable files. Lib directory contains DLL.so files. So, in Windows, we have .dll files, and in Unix, the same .dlls are called as shared objects or .so files. So extensions are there in share. So we have extensions and sample files are there. So that is what, the installation directory is. So, okay, one more thing you have to check here is ownership. So who is owning that installation directory? Let us go to the installation directory. So ls-ld, so PGSQL 14. So who owns this directory? Who owns this installation directory? Root user owns, right? So inside subdirectories also use root user owns, and inside the bin directory also everything is owned by root user. It is always recommended that the executable files, the library files, so they must be owned by root user. Okay, you let it owned by root user. The reason is they are more secure if they are owned by root user than they are owned by service user. Okay, so they are more secure. Okay, so that is what, that is why these files are, the executable files are owned by root user. Now come to our data directory. So this data directory is owned by, so this is what the ownership of the data directory is. This is the service user. The Postgres service user is owning the data directory. Okay, Postgres service user is owning the data directory, right? Inside that data directory also, everything is owned by service user. Always remember the data cluster data directory must be owned by service user. If any other user uses the data directory, so the service will not start. Or if you change the ownership of these files and directories, then also the service will not work. So Postgres expects these files to be owned by the service user. Okay. So our Postgres is running as, as a service under the OS Postgres user. So data directory layout. So a lot of files and directories are there. So PG version. So it is a file actually. So it contains the major version of the Postgres, that is 14 in our case. So there is a directory called as base, right? So this is a subdirectory containing, per database subdirectories. Okay. So current log file. So, there could be up to 7 log files by default. So if you are confused which log file it is currently written to, so you can always refer this file. So current log file. Okay. So you can always refer this file. So that tells you which is the current log file. So global, okay, actually this base directory and global subdirectory, base subdirectory, these are actually system and user table space by default created. Okay. So, so we have a slightly different concept of table spaces here. So, both of them are like, table spaces. We will discuss elaborate about table spaces later on. So PG commit, status timestamp. So, it will save the timestamps of all committed transaction, dynamic shared mem. So that is, containing files used by dynamic shared memory. So PG logical. So, you have a lot of, these things. So one of the important thing is, what we have means replication slots. PG logical is used by logical replication. PG replication slots is used by replication. So, so if you are using the serializable isolation level, if you use that isolation level, serializable, then it has to maintain the transaction order. So in serialized isolation level, transaction order is maintained. So how it is, generally in all other isolation level, it is a commit first basis. Let's say I started a transaction first, but you started the transaction after me, but you committed first. So your transaction is taken first. When I commit, my transaction is taken. So that is how in all isolation level happens. In serializable isolation, what happens is it is if I started the transaction first, so I must commit first, then only your transaction gets committed. So, it will extract that order of the transactions by using this directory. Okay. So exported snapshots are saved here, statistics and stats temp. I told you usage statistics. The usage statistics are saved in the disk in these two directories. Okay. So sub transactions, table spaces. So this directory is very important. When we go to the table space part, we will see. So what is the use of this? So, pgval is another directory where, redo logs are saved. The physical redo log files or val segments are saved here. So the physical val files are called as val segments. The val segments are saved in pgval. So, and pg exact subdirectory is there where, status of the transactions is written. And then we have some configuration files. As we proceed, we will learn about these configuration files. So this is what somewhat, the data directory, what we have. All data, all directories in the data directory are owned by service user. So right now it is Postgres. If you are using a different service user, then that service user uses it. The service user can be changed. It is not mandatory that the service user must be Postgres. That is default. If you want, you can run Postgres under a different OS user also. Okay. So whatever be the service user, data directory is owned always by the service user. That's the point here. Okay. So any questions here up till now before we go to the write ahead logging? Okay, I'm taking that as no questions and I am moving forward. Write ahead logging, as we know, because you are all experienced DBS, redo log means what everybody know. Transaction log. In some databases, redo log is also called as transaction log. And redo log, just log also, database log also, some database called it. Like, in MySQL, it is called as innodb log. So no redo log, no transaction log, no val. So it is called as innodb log. So whatever name it is, the main purpose of the write ahead logging is to provide the durability out to the transaction. So the compliance of ACID D in the ACID, right? Durability of the transaction. So that comes from val. So or redo log, or the transaction log. Okay, whatever you have. So the approach may be, the name may be different, the approach might be slightly different. So but the purpose is same in all databases, that is, so durability of the transaction. So, and how it is used, that is also same. Before any transaction is written to the data file, on commit, the transaction is first written to this val or transaction log or redo log. Okay. So it's a common concept in all databases. So the val central concept is that the changes to the data files so must be written only of those changes written to the val files. First you need to write to the redo log file. And after that, during the checkpointing, those changes are written to the data files. That is the very simple concept. So in all databases, that is the very simple concept. So that has, advantages. The main purpose is durability of the transaction. Apart from that, it also has some more advantages. One is there is no rush on the disk. So if all the transactions starts writing to the data file, so then there will be lot of IO generated, because many tables might be involved. Tables may be using different data files, and lot of data files needs to be written, updated, so it generates a lot of IO. Okay, if it is written to the wall segment, that is redo physical redo log file, only one or two, only at a time one file is opened, and every new transaction is written to the end of that file. So it is a stream. It is not like the pages, and the pages, it is not like that of data files. So they are not formatted, they are not in a particular format. So the transaction, the wall segment files are like a stream of entries, so you are always writing the new entry at the end of the file. Okay, that's the reason writing to the val file is much easier than writing to the data file. And you are opening just one wall file, even though the transaction might include 7 8 tables, but still you are opening just one wall file. So that's the reason writing operation is much faster here compared to the writing operation of all 7 tables needs to be updated. So you need different data files are there, so all those data files needs to be updated, means lot of IO, more than one file you have to open, so lot of IO is generated. So that's the reason, the wall approach gives us two benefits. One is, so it gives us more than two benefits, but right now focus on two benefits. The benefit number one is durability of the transaction. So your database will become, your database is becoming more reliable because of this wall, because transactions are durable now. The number two is, so you are avoiding the IO rush to write on the disk. So these are the two advantages, immediate advantages we have with the WAL files. Okay, the WAL files are also, useful for, the roll forwards. So if a crash happens, Postgres service is, Postgres service is what we say means, uh, so if a crash happens, Postgres service is started back, and Postgres will perform what we say means recovery. So from the val files automatically crash recovery. So that is called as, that action is called as redo. So that is the advantage of the val files. Any questions here? Okay, roll back and undo information. What is the purpose of undo? So undo, every database will have undo. Okay. So what is the purpose of undo? Some databases have separate undo files. Okay, like Oracle has separate undo log file.
It will store the previous value before making the changes to the actual update.
Yeah, the before making changes to the data, so the original copy of data is saved in undo, right? So what is the
Yes.
purpose of that? Why we need to save it?
To roll back if needed.
Yeah, if you roll back the transaction, you need the original copy of the data, right? So that you get from undo. So that is the purpose of undo, and it plays a very important role in transactions. Without undo, you cannot roll back, right? You have to commit or you lose the data, so but you cannot roll back without undo. So that's the reason undo is very important. Undo is very important for any database. So there are different approaches how we write this information. For example, you take InnoDB of MySQL and you take Oracle, they write the undo in a separate file. So there is a separate file, they maintain the undo data, right? Okay. So in SQL Server, the undo data is written in the transaction log. So the transaction log contains redo and undo data in SQL Server. So, different methods are there how every database maintains the undo information, but undo information is necessary for rollbacks. Without undo information, so you cannot roll back. Postgres has a very novel method of, maintaining that. Okay. So actually not maintaining that. Postgres does not maintain the undo logs. There are no undo logs in the Postgres. Okay. So, but the undo, the rollback is there. Without undo logs, Postgres will do rollback. So that is what, the good thing are, that is what the simplicity of Postgres is. It also added to, because of this approach, it also added to some other problems, but it is the simplicity because, so if you are generating the undo log, the database for each transaction, the database is doing some extra work, right? So, that work Postgres is not doing. So that means the transaction time is reduced, right? The faster compared to other databases, the transaction is completed faster. Okay, so that is a good thing actually. So, but it also added to other problems. Okay, so it has improved the speed of transaction and simplicity of in doing the transactions. But it has added other problems also. So we will see, okay, how the Postgres do the rollbacks and how Postgres maintains the undo. So as I said, Postgres does not maintain any undo log. There is no undo log in Postgres. Okay, so let us see about dynamic disk allocation. Dynamic allocation of disk space is used for storage and processing of records within tables. So here we are talking about, the tables. Okay, so something we need to know about the Postgres tables storage is, okay, each table has its own data file. No data file sharing. Okay. In other databases, data files are shared. You take Oracle database. Many of you are familiar with Oracle database. So you create one table space that may have one or two data files or more data files, all the tables which are in that table space shares the same data file, right? They are sharing the physical data files, right? The tables are sharing physical data files, including the indexes, correct? In Oracle. In Postgres, every table will have its own dedicated data file. Every table will have its own dedicated data file. If you have 10 tables, that means you have 10 data files in that. The Postgres tables does not share the data files. So this is how the Postgres is designed. No data file sharing. Okay. So every table will have, including indexes, every table or index will have their own data files. So that is what, the Postgres storage is. Okay. So the data files are again, so they are, like other databases. Like other databases, again, the data files are formatted or, divided into what? Page. So it is also in other databases called as block, right? The size of the page or block by default is 8 kilobytes, as we discussed yesterday. So the data files are, divided into the blocks. So each block is 8 kilobytes. So every table will have its own physical data file. They don't share the data files in Postgres. So if you have an EMP table, so, the EMP table will have its own data file. Okay. So EMP table will have its own data file. Okay. So that is how, the storage will be for Postgres. And the size allocation is dynamic. Data file size allocation is dynamic. Dynamic means dynamic means what? Let's say I have created one table. So let's say, I have created one table called as sales. So I have created a table called as sales. Okay. So when I create a table sales, so a disk file is created for, the sales, for sales table, a disk file is created automatically. So there is no need for a DBA to do anything for that, just create the table. So whether it a DBA is creating, whether a developer is creating or an amateur is creating. So, as soon as, the table is created, so a disk file is also created. Okay. And at that time, the size of the file is 0 bytes. So a 0 byte file is created, empty file is created. Okay. Then the next step is, somebody did one insert or one or two inserts. Okay. So when the first insert is done, one block is added. One block added. So that is, the file size will become 8 KB. So one block is added. So then the file grows, right? The data grows. So more data is added. More data is added. Okay, the file size keeps on growing in 8 kilobyte. Okay, 8 kilobyte, okay, blocks. Every time, it needs to extend the file size. So it will add 8 kilobytes. Okay. So after 16, it will be 24 kilobytes. After 24, it is so 32 kilobytes. It will go on extending like that in 8 kilobytes. So this is called as dynamic data file size allocation. Okay. So there you cannot set a size for the data file. Generally in Oracle and other databases, so what we can do is we can create some data files, and then we can set the size to them. So we can say the maximum size is 1 GB, 2 GB, we can say. So now once you set that maximum size, one of the duty of the DBA is to monitor the size in that file, right? How much free space is left in the size. Okay, a lot of maintenance activity happens, lot of monitoring activity happens in the databases for size monitoring. So and some tables, some files may have auto extend, some may not have. So but as a DBA you still need to monitor the file sizes, how much free space is there in each of the data files. Here in Postgres you don't have that headache. There is no need to monitor the file size. Automatically, the files are extended in 8 kilobyte blocks. So 8 kilobyte blocks, automatically the files are extended as the data grows in the table. 8 kilobytes are added to that file. Okay. So that is called as, the dynamic data file size allocation. Okay. So this is how the data. When you create a new table, the size of the data file is 0 kilobytes. Okay, 0 bytes. When you do the first insert, even if it is just one row insert, so 8 kilobytes is added. So then, if that 8 kilobytes is full, then, it will add another 8 kilobytes, then another 8 kilobytes dynamically. So the size is extended, or, it will auto extend the size in 8 kilobyte blocks. So that is how, so it goes. That is how, the file sizes are managed. Okay, the file that represent the table grows. So the table grows as you do more inserts, your file will grow. It starts with 0 bytes and it will keep on growing. It will keep on growing, right? Up to 32 terabytes. Each database can grow, each table can grow up to 32 terabytes. So that is the maximum size of table in Postgres. So it also grows with the transactions which are performed against it. Okay. The data is stored within the file, represent the table. Okay. When the deletes are up and deletes and updates are done on the table, so the file that represent the table will have the previous data. So, let me show you. So what it means here. Okay. So let's say, I will come back to a normal example. So let's say, so we have a data file here. So we have a data file here, whichever table it is, sales, EMP, it really didn't matter. So we have a data file here. Let's say some rows are there. Let's say some rows are there in this. Okay. So let's say some 5 rows are there, or 100 or 1,000 rows are there. So like, this is, the primary key is 10, primary key is 11, primary key is 12, primary key is 13, primary key is 14. So we have, these rows, we have 4 rows, 5 rows. Okay. So that's the thing. So what I am doing is, I am doing a transaction here. I'm doing a transaction here. So let's say this table is, orders. Update orders. Set, we have where, let's say ID is equal to, so 13. ID is equal to 13. This is the change I am doing here. Okay. So this row I am trying to change. So what happens is, when this transaction is active, so, so what happens here is, so when this transaction is committed, what actually it does is, when this transaction is committed, what actually it does is, at the end of the table, so at the end of the table, okay, so it will reinsert that row. So it will reinsert that row. At the end of the table, it will reinsert that row. Okay. And the existing row, so will become dead. So this row will become dead. This row will become dead. So we call it as dead rows. So this become a dead row, but still it exists. Okay. So the green ones are, these green ones are live tuples. So are live rows. Tuples. Row is a tuple in book term. And the gray ones are, dead rows. Dead rows. So how Postgres did do the transaction is quite different than other databases. So when you do the transaction, especially the update or delete, actually it is not performing that update or delete. So it is not performing the update, it is performing an insert. In Postgres, when you actually update a row, it is not updating a row, it is performing an insert. With the new row means the row is inserted again with the changed values. The older version of the rows still remain in the data file as dead row. So that will remain in the data file as dead row forever. Okay. No query can see. The dead rows are not visible to any queries or anything. So in no tools also can see the dead rows. Okay. So sometimes you will come across a situation. Right now it is quite impossible, but with older versions of Postgres, so you may, if you are dealing with 9.2, 9.3 version of Postgres or 8.x version of Postgres, you might come across a situation where, so you have a table whose physical size is, let us say, 1 GB or so, it might have 10, 15 rows in that. The actual rows are 10, 15, but the file size is showing 1 GB or 500 MB. So very large file size, but actually the number of rows in the table might be so less. And you should feel that, the actual size of the physical files of the table can be 8 kilobytes or so, 8 kilobytes or 16 kilobytes. That is because, whatever updates are happening, so those rows still remain as dead rows in the data file. Postgres during the transaction or after the transaction does not remove them. So they will remain forever in Postgres. If you do the delete, then the situation is same. So the deleted row will become dead row and it will still continue to remain in the data file physically. Okay. So none of the queries or none of the tool will be able to see them, but physically they occupy the space. So that is what, the dead rows. Why the dead rows here is, why it will do like that is, Postgres does not do an undo log. There is no undo log in Postgres. The original row is used as undo during the transaction time until other transaction requires that, that row is pointed to by the other transaction and the original row will be used as undo. Okay. So that's the reason Postgres does not write the original data into another file. So it will speeding up the transaction by doing that. So it will avoiding extra work during the transaction, which will help in reducing the response time, okay, for the end user. But however, so this is one benefit it is giving, but the downside of it, or by that, the problem with that is, you have dead rows. You will end up having a lot of dead rows in your data files. So everybody understood why we have dead rows. So this concept is only in Postgres. Other, as far as I know, other databases does not have this type of thing. So other databases, every other database maintains the undo logs and every other databases so will not have the dead rows which are not cleaned forever, right? So your actual tables may become bloated. This will give rise to the bloating and all. So how to manage this dead row situation is, so you can use vacuuming. So you can use vacuuming here. So if the tables are vacuumed, so for example, if this table is vacuumed, so what happens is, if this table is vacuumed, what happens is, so the dead row space is marked for reuse. So this is marked for reuse. So this space will be reused by the next insert, might be because of the insert statement itself or because of the update statement. So that space is reused. So this is called as vacuuming. So this is called as vacuuming. Okay. And there is another variation of the vacuuming, so which is called as vacuum full. In vacuum full, what happens is the data file size is compacted. Okay, the dead rows are removed and the space is also released. Okay, the space is also released to the OS. Got it. So you can do the vacuuming in two ways. So vacuum and vacuum full. So in vacuum full, actually it will, so in vacuum full, actually it will, what it will do is, so it will remove that free spaces, dead tuples and their occupied spaces, and it will shrink the table size. So in vacuuming, so table size is not, data file size is not shrunk, but that space which is earlier used by the dead tuples is marked as free space so that the next insert can go into that. Okay, so that is what the vacuuming is. So the concept of vacuuming is not there in any other database. The, the existence of dead tuples is not there in any other database. As far as I know, the databases will, so manage their transactions without creating the dead tuples. So that is in Postgres, this is different. Undo logs are not maintained. The original row entry is used as undo. And when a transaction, update transaction is committed or delete transaction is committed, so, the new entry means if it is an update, so a new row is inserted with changed values, or that row is reinserted as changed values. And if it is a if it is a delete transaction, so that row is marked as dead row. So any questions here?
Hi, Sami.
Yes.
That go to that vacuum and vacuum food. So what is default? I mean, when we can use vacuum, when I mean it is our choice or it is by default if it is vacuum, or if there is any
Okay.
situation came like we need to use vacuum food.
That's a good question. And, if you are doing it manually, so it is your choice. If
Okay.
auto vacuum is doing, we saw that auto vacuum process, right, earlier?
Yes, util process.
Yeah, so that will perform the vacuuming on tables. So if it is doing, it will do vacuum only, not full. Okay. Automatically, which is done by the Postgres, it is vacuuming. So if you are doing it manually, you have the option.
Okay.
Either do
Then
full or vacuum.
okay, got it. Thank you.
Any other
Sami,
questions?
Sami, the
Yes.
index also stores on the same data file only, or it will create a new
No,
data file?
index in Postgres, every table and every index will have their own data files. Okay, neither the table share the data files nor the indexes should share the data file.
Okay.
Okay, so this is how it is by design.
Suppose in case if we are doing the vacuum on these tables, we don't need to rebuild the indexes, right?
You need to time, you need to reindex.
Okay.
Okay. So any other questions? Okay, everybody is clear about the vacuuming, right? So why we need to do the vacuuming? Why? So what is vacuum full and what is vacuum? So why we get the dead rows and how Postgres manages without undo logs? Everybody is clear about this? So if we are clear about this, we can take a break. So come back. Okay. So after the break.
Okay.
So 4:15 we will come back. थोड़ी सा जल्दी दो टाइम 15 मिनट Okay, guys, hope everyone is back. Everyone back? Okay. Okay, let's get started again. So any questions about our, what we say means live tuples, dead tuples? And the undo logs. So, everybody is very clear about this, right? Okay, so everybody is also very clear about vacuum, full vacuum and auto vacuum also. Okay. Now coming to the data file storage. As I told that, the, okay, you guys are able to see my screen, right? Yeah, looks like.
Yes, we are able to see.
Okay. So as I said, every table and every index will have their own data files. So they will have their own data files, every table and every index. So, so no file sharing here. So no sharing is caring, so does not apply here for Postgres tables and indexes. So everybody will have their own. Okay. A table space is a directory here because in other databases the table space concept is different. So table space concept is different in other databases. So in other database, for example, I know the SQL Server in Oracle. So you have a table space in SQL Server in Oracle, SQL Server in Oracle. So table space in SQL Server, the table space is called as file group. So Oracle and SQL Server. So you have table space or a file group. So which points to several data files are at least one data file, right? So it points to several data files are at least one data file. It could be just one, or it could be more than one also sometimes. So it could be more than one also sometimes. Okay, so one or more files, data files. And when you create a table on the table space or that file group, so the table can use any of these files or, sometimes both of them also, right? So this is how, in Oracle and SQL Server, whereas in Postgres, so we have a different thing. Postgres, we have the concept of table space. Because here we don't share the tables don't share the data files. and indexes also don't share the data files. So that's the reason the table space is pointing to a directory. So it points to a directory. So it points to a directory here. Every table space is pointing to a directory. So any table or all the tables and indexes which are created, so that table space, so will have their data files saved in that directory. So the directory is also like, it will also have subdirectories. Like yesterday we discussed, Postgres is a cluster of databases, right? So you always have many databases. You can create many databases like the latest Oracle or SQL Server or yesterday some, so DB2. So also we learned that it is like that. So it is a cluster of databases. You can create, many databases. So the table space may have a subdirectory for each database whose tables are using this table space. So database subdirectory. So it may have data, subdirectories for each database. So that is what, the table space, that is what, the table space is. So in Postgres, it points to a directory. In turn, the directory can have subdirectories. So, and every database, every table, so which uses the table space, so we'll create a subdirectory for that database to which the table belongs to. And in that subdirectory, actually, the table data files are saved. So data files are saved here. Either table or index. So this is how the table space is in Postgres. So we have a dedicated topic to the table space. In that we will learn how to create the table spaces. Maybe we will learn more about table spaces and how to create a table in a table space. Okay. So that is what, that is what the table space is in here in Postgres. Any questions here regarding table space? Any questions here? So I'm assuming no questions. So table space is a directory. Each database that uses the table space gets a subdirectory. So as I said, for each database, there is a subdirectory. Here more to the data files. As I said, every relation that is either a table or an index. So relation. So every relation will have its own data file. Okay. So those files are saved in the table space and database subdirectory. They are saved in the data files are saved under the database subdirectory in the concerned table space. Okay. In 1 GB chunks. So that means, a table when you create, so it will get a 0 byte data file. And as you perform the inserts, the file size may grow till 1 GB. When the file size becomes 1 GB, okay, it will add one extra file to that table again. So the table is not always having either the table and index, not always having just one data file. They may have multiple data files, okay, based on the table size. So they may have multiple data files based on the table size. So in 1 GB chunks. There are few other files are also maintained per table. So one is data file, at least one, or sometimes, more than one if the table size is more than 1 GB. So apart from the data files, so, there are two more files are maintained. One is called as free space map and other file is called as visibility map. For each relation, either an index or a table, a free space map FSM and visibility map VM is maintained. We will see the purpose of these two extra files. And each file name is a number. If you create a orders table, so the data file name is not orders, but every object in the Postgres have a object ID, a number. Internally, every object is assigned a number. So internally, every object is assigned a number. Object name and object ID or OID. Object ID or OID. Every object will have OID, object ID. Okay, including the tables, including the indexes, users, databases, schemas, table spaces, any object you create within the Postgres, including views, sequences, everything you create. Every object you create, so that will have an object ID and object name, both will be there. Object name is for the user. We cannot remember the IDs, right? But internally, Postgres processes the objects as per their object ID. Okay, so every table will be having an object ID, and usually in most of the time, so the data file name is, the object ID of the table. Okay, the data file name is object ID of that particular table. So that is what, our, data file internals are about. Okay, so let me show you real quick here in our lab. So let me connect to PostgreSQL. I have connected to the PostgreSQL. You want to know how many table spaces are there right now. So the DB command tells us about the table spaces. Right now we have two table spaces, PG default and PG global. Okay, two table spaces are there, PG default and PG global. So the PG default table space is where, some of the system data and user data is saved. And PG global is a system table space where, the metadata or, the data dictionary related to global objects is saved. Okay. So, the data dictionary related to the global object is saved. It is purely system table space. Like in Oracle, you have system table space and at least one user table space by default when you install, right? So here, so we have a PG default and PG global. So there are objects which are defined as global objects, and there are objects defined as local objects to the database. Okay, some objects are local to the database, like a schema is local to the database, a table is local to the database, index is local to the database, but the database itself is a global object. Database itself is a global object, right? So, some of the objects are classified as global, some of the objects are classified as specific to database or local to the database. So, the PG default contains user data, table space contains user data and metadata about local objects. PG global is the system table space where the metadata about global object is saved. So where they are saved, so where they are saved. So PG global PG global, it is saved in data directory, global directory, and PG default, it is saved in data directory base. So there is in the data directory, there is a directory called as global and base. So by default, that is one is the global table space and other one is the PG default table space. Okay. So that is about, our table spaces. Okay. There is a data dictionary table called as PG class. Okay. And it has a column called as rel file node. It will tell us the number of our data file. For example, let me go here. Let me check how many databases are there. So I give the command \L. So this \L give me a list of databases. So it is giving me the list of databases. So So right now we have three databases. As you can see, there are three databases here. So you can see there are three databases. One is Postgres database. Other one is, template 0 and, the template 1. So Postgres, most these databases does not have much significance. So, you can, remove those databases. So by default, they are created, but, they don't have any system function. Postgres can work, okay, without these three databases also, but you need some other three in at least one you need in their place. Okay. So if you give a command con info, connection info, what it is saying, you are connected to database Postgres as user Postgres via socket. So we are using unique socket connection. We are not doing a TCP connection here. Okay. So this is what, the con info is giving. Right now I am connected to this database Postgres. So if I create a table, the table is going to be created in this database Postgres, not in template 1 or template 0. Okay. So as a user Postgres, if I create a table now, that table going to be owned by this Postgres, that is super user, database super user. Okay. So every time you connect to the Postgres, you must connect to one database. Okay. Always you are connecting to one of the available databases. Okay. So the con info is the command which gives you information about the current connections. Okay. So con info. So it tells you about, your details about your current connection from the PSQL. So that is what, we have three databases. The Postgres is, for many of the administrative purposes, So we connect to this database and perform. So you can perform the administrative task from other databases also. But the thing is, we don't prefer to, because other databases are application databases. We don't want to disturb them, right? So that's the reason whatever our administrative task is there, like vacuuming, so we perform by connecting to the Postgres database. Okay. So, and the template 0 and template 1, these two databases, they are there. So they are there. So as templates, if you create a new database, so this template 1 is used as a reference. So this is used as a reference. So template 0 is a read-only database, so that this template 1 is can be changed. Means you can make changes to the template 1. So for example, if you want the original template, so always you have template 0. So this will contain the original template, and this you can modify. You can also create a database and you can also use it as a template. So, there is no rule that you should only use this template 1 as a template for new databases to create. So you can have your own database also as template. Okay. So that's the reason, so at least you need one database which acts as a template for creating any new database. Without a template, you cannot create a new database. So these are the three databases we have. They don't have any system function except the template 1 or template 0. They can act as template if you're creating new database. That is the only function of these two databases. So Postgres database does not have any specific function, right? So it does not have any specific function. So for performing any administrative task, you might need to connect to Postgres. So you need a database to connect. So that is what the Postgres is. So for performing the administrative task, if you have an alternate database, so any normal database which you want to use for administrative tasks, you can very well drop that database Postgres. It has no significance. As I said, you can drop all three databases. Okay, but always remember, to create a new database, you must have a template. Without template, you cannot create a new database. So that's the reason. So, dropping the template is, the timing. So if you have already a new template, then you can drop the old templates without any problem. But don't drop the template databases without having another template. Otherwise, you will not be able to create a new database. So that is about, that template databases. So for example, right now, how many tables are there? Right now, I don't have any relation. I don't have any tables. Okay. Okay, I don't have any tables. Let me create a table. Create table T1. So ID integer. So name, where, care of 10. So, so this is the table I am creating. So a 2-column T1 table I am creating. So, I have created this table. Now I will do this one. You can see. So I have a new table here, T1. So you can see some of the information. So there. So it gives what is the schema of the table, name of the table, type, and owner. In Postgres, the schema of the table and the user can be different. So in Oracle, generally it won't differ, right? So the owner of the table and the schema both are same. In Postgres, they can be two different things. Okay. So that is how I created a table. There are some data dictionary objects here. So like users table, there are some data dictionary objects, right? We also in the Postgres, we have data dictionary objects. Select star from PG underscore database. PG, if any table name is starting with PG underscore, that means it's a data dictionary object. It also has the same information, dat name, OID. You can see OID, dat name, and other information is also there. So Postgres template 1, template 0. So 3 databases, 3 rows, 1 row for each database. So I will make it better. So I will say OID, dat name. Dat name means database name from PG underscore database. So it is much better. So you have the OID of the database and you have the database name. So this is how you can make use of your data dictionary objects. For database, this PG database contains the information about databases. What about the tables? Where that information is contained? So that is contained in a table called as PG underscore class. So this table contains that information, PG class table. So there are a lot of issues here, there are a lot of columns here. So it's a very big table with lot of columns, but some columns are there. Rel name. So you should not say table name, rel name here, relation name, and rel file node. So you can see there are a lot of, but what we want is just for T1. So just for T1, right? So OID of the T1 table is 16384. For rel file node of the T1 table is 16384. Okay, the data file name of the T1 table, the data file of T1 table name is also 16384. So that is what. Okay. So just give me 2 minutes. I will be back in 2 minutes. Okay. So quick 2 minutes break I will take. Okay, I'm back. Sorry for that. So let's get started. So I was showing you. So I was showing you this one. Okay. So the rel file node is what this one 16384. So each of the object, whether it is a table or index, will have an OID. So I will also visit our previous command. So that is, the OID of database name. So our T1 table is in Postgres database, whose OID is 1374. It is very important. So just exit from here. And I am in data. So if I do a ls, I have this base directory, which is PG default table space. Okay. So in the base directory, you can see there are 3 subdirectories. 13747, 13748. So if you look at this Postgres OID 13748, so 13748. So we created our table in Postgres database. So our tables data file is in this. So CD 1378. So 74. Okay. So this might have a lot of files, but we want to look for, the rel file node of our T1 table. Okay. Which is equal to, the OID also. Okay, so I can say, ls-l. So what was that rel file node? So, so just to right click, so it will get pasted. So this is the data file, and you can see right now the size of the file is 0 bytes because we created the table, but we have not inserted any rows in that table. As soon as I insert the first row, so the table size will become 8, the file size will become 8 kilobytes. So this is how you can find out. So where is your, what we say means, so where is your, data file belonging to the table? So any questions here? So we are almost done with our, so architecture lesson. So almost just one topic is there. So once that is over, so
Sami,
we are almost.
Sami, one question. Like Oracle, this data files and table space can't we see with the queries?
That's what I did, right?
No, we from the OS level we are looking at, right? Size
No,
and
these are select query, man.
no, not from the select query. With the ID, we went into OS prompt.
Okay, you mean to say the data file, right? So that is what, the OID, the OID rel file node is there, right? That is our data file.
Yeah.
Okay. Find your table data file. Okay. So I have given all the steps. Okay. So right from, so finding the rel file node, this is the data file name, rel file node. Usually it is the OID. Okay. So, this, then, your OID of your database. So then you can go to exit from here, then go to the OS and then you can find. Okay. So that is what. So
that we got it.
What.
So from the database, we cannot query, right?
That rel file node itself is the file name.
Okay.
So you cannot query the path. So if you want to know the full path, you have to put together pieces. So it will give that information in pieces. The file name is rel file node. Okay, the subdirectory is the OID of database, and the table space directory path, that path of the table space. So when we go to the table space, we revisit your question. So you will get more quality, more clarity on that.
Okay.
But there is no
Sami.
single query which gives you full path.
Okay. Okay.
Hey, hi, Sami. So, hello.
Yes, yes, ask. I'm
Uh-huh.
listening.
PG database, that is global, I can say table, global system table, and PG class, that is local, right? I mean, PG database, if we query database, what all the database is present, we
Yeah, the
query.
PG database. Yeah. The PG database table is a global, that is it resides in PG global table space. Whereas PG class, okay, it is a local object specific to database. Every database will have a PG class of its own. Okay.
Okay.
Every database have its own PG class table.
So first we need to connect the database, then we can query that one. That only we get
PG
the
class.
table.
Yes. Yes. So if
Okay.
you like T1 table is created in Postgres database. If you want to work with T1 table, you need to connect to Postgres database.
Then we can query. Okay, got
Yeah.
it. And table space, it is create under database, right? As you said, table
No.
space we have directory when we create, it
A
should be.
table space is also a global object equal to database. They are parallel. They are not under.
Okay, table space is
Okay.
also global.
Global. A
So,
user, table space, and the database, three are global objects.
so tables are logically present in table space, or it's logically present in data. I mean, of course, it is present in database, but logically it is under table space, because when we create.
Physically, it is under table space. So every table will be physically present under table space, logically under database, right?
Okay.
So any database you take, physically the tables are present in table space only, in the data files belonging to that table space, right?
Hmm.
Okay. So, and the database, it will be present part of the database, part of the schema. So we will see, so when we go to the topic of objects, right? So we will see, so the hierarchy of the objects also. Okay.
Okay.
Sami, one question. This PG default table space will act as like a sys table space or user table space.
It is a user table space and also sys table space for local objects of that database.
So
Okay.
it has
So
dynamic tables and metadata also. This default
yeah,
table.
your user tables, your user objects metadata will be there in the default PG default. And also, every database will have some of its own metadata, right? How many tables it got, how many schemas it got, right? So
Okay.
that meta information is also written in that PG default.
So now this table is residing under PG default, the one which we created. Can we say like that?
Yes, yes, right now,
Okay.
because we don't have any other table space, right?
Okay. So it gets created in the PG default.
Default, by default.
Okay. Okay. Thank you.
When we create our own table space, then we have a choice.
Okay. Okay. Got it.
Right now, we don't have any other table space. We don't have a choice. It will definitely go into the PG default.
Okay.
Any
Sami,
other questions?
yeah, Sami. Sami, here I can see like a schema, right? What is the significance of schema here?
Schema is, the logical collection grouping of the objects like tables. Okay.
Okay,
So, it is like, the tables are grouped under schema and the schema is under database.
okay. Then it is showing as public, like under scheme,
Yeah, as
like.
I said, in Postgres, so
Hmm.
schema name and owner table or user name can be different.
Yeah. So like
It
public,
is allowed.
private, some other options are also available, or why it is
No, no,
public?
not private. By default, a public schema is created. Every new database will have a default public schema. Okay.
Okay. Okay.
So it's a default public schema. Every database
Mm.
will have a default public schema
Only
named
public.
public.
Only public.
You can create additional schemas. So we have a lab exercise for that to create
Sure.
additional schemas.
Okay. So in that case, like I can put it in that schema then.
Yeah, if you want your tables to be in a separate schema, you can create a schema and you can put your tables in that schema.
Okay. Okay. Fine. Thank
Okay.
you.
There are a few differences between the Oracle schema and the Postgres schema. One is the user's name and schema name can be different. In a schema belonging to one user, other user can also own objects. Okay, so that is two. These things are allowed in Postgres.
Okay.
In general, in Oracle, it is not allowed, right? If a user owns a schema, only that user can own the objects in that schema, right?
Correct.
Others can use, but others cannot own. That's what I know.
Yeah. We
So
can permit for the user to view or access.
yeah, but here, you can permit the user to create the object, own the objects also.
Okay.
So a bit of flexibility is there, I can say. So, it's a bit of flexibility we have regarding the schema. Schema is not strictly defined and maintained like Oracle here. It's a bit of flexibility is there. So we have a separate topic for schema. So we will get more clarity on that.
Sure. Sure. No sure.
Any other questions? Okay. So as I said, every table will have a data file, maybe more than one data file also if the table is big enough. Okay. So each table, apart from the physical data file, every table will have two more physical files. So two more physical files are associated with the table. One is free space map and other one is visibility map, FSM and VM. The free space map stores the information about free space available in the relation. So free space map stores the information where all the gaps are, where are the free spaces available. So if you look into our diagram here, so you can say free space, right? When you will have the free space within the data file. So if you do the vacuuming, only vacuuming, so the dead tuples are removed and that space is marked for reuse. So that is the free space. The next insert, which might be an insert or which might be an insert because of update. So whatever it might be, the next insert will go into that free space. How the next insert will find where the free space is, that is from the free space map. So the free space map helps the transactions to find the available free space in the data files. They will find the process which is writing the okay data, right? So to find the free space in the data file. Okay. And visibility map is also there. Track which pages are known to have no dead tuples. So it will track all the pages, 8 kilobyte pages where no dead tuples are there. Means they are all clean. So what is the purpose of this visibility map? How it is helpful? So it only have the list of pages where there are no dead tuples, all clean tuples, live tuples are there. No dead tuples. What is the use of this information? Anybody? So very simple, the vacuum, when you are doing the vacuum, it won't touch those pages because all tuples are live tuples in those pages. it only touches the rest of the pages which are not in the VM. So rest of the pages, so it will touch and it will, do the vacuuming only on the pages where dead tuples are there. That way the vacuuming runs efficiently and finishes within less time. Otherwise, if it has to look into all the pages, means it may take a lot of time. Now it will just find which pages have, dead tuples and just vacuum them. So that is the purpose of the visibility map and free space map. These two additional files are associated with each table. Okay, that finishes our architecture lesson. And if you have any questions, so regarding anything regarding the Postgres architecture, right from the processes, memory, data, or disk files, and the how it works, so you can tell me now. You can ask me now. Okay, so I don't have any questions. Okay, that means everybody is clear about architecture, right? I'm asking again and again. So why? Because this lesson is very important for us. It is the foundation of entire course. Okay, so our next topic is Postgres client. So most of the theory part is over. From now onwards, it is less theory and more demo and practice time. So today what we will do is, quickly I will complete this client. So we have two main clients. So one is the command line client PSQL that already we have seen we are using. So that PSQL client has some options. So we will see those options right now. So we will see those options. And the other client is, PG admin 4. So this is a GUI client which runs as a web server. It runs in the web server mode. You can also install it on desktop. So it has two versions, desktop and web server mode. Web server mode version is very, very helpful, very, very useful if you are planning to maintain a lot of PostgreSQL servers. So it is always recommended to use in web server mode. So it will ease your operations. So it will ease your operations, make your operations smooth. So that is web server mode. We will see the web server mode in our in our class. We don't see the desktop mode because there is nothing to learn here. You just install like Toad or so um, any other GUI client like Toad. So you can install and you can use it right away. There is no need to learn anything there, right? So that is what the desktop is. But whereas web server mode, so it required some installation part and other stuff. We will see that. Okay. So in our course, we are including this web server mode. So of PG admin 4 GUI. So first of all, we will go to our PSQL. So the PSQL. So let's do some PSQL experiments here. So right now, okay. So coming back to our PSQL. So sometimes Windows sucks. Ah. Okay, so here we have so connecting to PSQL. Just simple, I'm connecting to PSQL. So it will connect, right? It has connected. So where it has connected, what are the information, how it is connecting? So, it is connecting to Postgres database. It is connecting as user Postgres and it is doing a unique socket connection. Okay, unique socket connection. Okay, Postgres cannot do named pipe connection. Only unique socket or TCP connections it can do. Okay, so but I didn't ask it to connect to Postgres database. I didn't ask it to connect with the Postgres user. I didn't ask it to connect with the using socket, right? So all this it is doing by default. So I can change this. So for example, I am doing the same PSQL right now, and I am giving the host name. So loopback IP address I am giving. Okay. So now it will connect. So it is asking secret, right? So the password is secret. Now it has prompted for password. When I was doing, so when I was just doing PSQL, it didn't prompted for the password. Now it is prompting. So now you do con info. What is the difference here? What is the difference? Anybody can tell?
Host name is mentioned.
Yeah, it's a TCP connection. That means. So that means what? TCP connection. So if it mentions socket here, that is a unique socket connection. So if I had mentioned host here, that means, it is doing a TCP IP connection. Okay. So TCP IP connection, I asked it to do by, just giving H. So PSQL, so exit from here again. So, again exit from here, again run the PSQL. So database is template 1. Okay. And then again, I am saying H127.0.0.1. Oops. 1. Okay. Secret. So now you do the con info and it will tell it is connected to database template 1 because I have specifically mentioned database template 1. So this is how you can connect to a particular database. Because I have given the host name, it is doing the TCP connection now. Okay. So here, if I don't give the host name here, so it will still connect to the database Postgres. So, but sorry, database template 1, but as unique socket, right? So that is what, you can connect to a different database. So you can connect to different database. Okay. So you can also change the port number. So, you have a lot of options here. So, if you are connecting to a different port, you can also mention port. So I'm giving 6432. So sorry, 6452. So this is the port I am giving, but our Postgres is not listening. So, this connection won't be successful. So, what it is saying is Postgres is not running. So it is saying because Postgres is listening right now on 5432 port. So we will later on see how we can change that. But right now, so it is this port. Okay, you can use the port like this by giving -p. So there are a few other things with the Postgres client. So for example, you want to execute one statement. So, without connecting. So what I am doing is I am giving one statement, select star from T1. Okay. Select star from T1. So it will connect to the database and it will execute this statement. It will execute that query and come back to the command prompt. So it has connected to the database. It executed this query. So we have created the table, but we have not inserted any rows. So after executing that query successfully, it came back to the Linux command prompt again. Okay. So if you want to write any, what we say means, so if you want to write any scripts and all, so you can do it from here. Sometimes, we also want to do the scripts, right? Sometimes we also do the scripts, .sql files, nano test.sql. So I'm writing a script. I'm saying select star from T1, select so OID comma rel name from PG underscore class where rel name is equal to T1. So this is the second query I had given. So maybe you can go on adding more and more queries. So whichever SQL statement, I think, so as part of your DBA, so at some point of time, you might have created scripts like this, right? And then executed them, right? So normally we do and exit. Okay. So I have my test.sql. So this is the test.sql I have created. So I want to execute this file now. So how I can execute this file is simply I can say psql /f test.sql. So this /f tells which file, and it has executed the first query, that is select star from T1, and the second query is from PG class. It also executed that second query. So this is how you can execute a, what we say means, so execute a .sql file. We
So
have
does
to,
not we pass the database name?
if you want to execute this in a particular database, you can also pass the database name also. Okay.
Because T1 is
So the
default
first,
present in Postgres, that's why maybe it is connected, right?
yeah, that is default. Okay.
Okay.
So if the username is Postgres and if there is a database name Postgres, it will connect. Okay. So that is the default behavior. So if you don't mention the database, it will try to connect to a database whose name is same as username. So, if I do the template, if I execute the same script on the template database, so template one database, so, the first query will fail, right? Because, there is no
Yes,
T1 table.
correct.
And the second query,
That is also failed.
second query,
It is also failed because there is no
it
in condition you pass real name is equal to T1. That is not present now.
yeah, so it won't fail. It won't show any data. Because the condition is not matching, right? So it won't show any data. So it is an empty query.
Huh.
it will return empty set, the first query will fail. Okay, you can see this, select star from T1, so it is already failed. T1 table does not exist in template one database. So whereas this query did not return, the second query did not return any data because the where condition I have given, so, it didn't match. Find a match. So, that is how, you can pass on a particular database. Right?
Yes, correct.
So you can also use a TCP connection here. That's for the password. So if you don't want to give the password, so you can also use capital P secret. Okay. I think you cannot pass the passwords, right?
Is secret password for template one also?
No, it is secret is the password for Postgres user.
Yeah,
So
so if
yesterday we set the password for super user, right? Postgres. So here a lot of Postgres are there. There is a database called as Postgres. There is a database user called as Postgres. So there is a OS user called as Postgres. So you can also see all the options with this PSQL help. It will show you all the options. Okay, for password, you have to give W. So for password, you need to give W.
I mean, capital P is for port.
Small p is for port.
But here it is showing capital P.
Oh, is this capital P?
It looks like a capital P. No, it's
Yeah.
a
Okay, so so here you have capital P.
Mhm.
Okay.
Oh.
So let me do it again. So I am saying capital W secret. So it is not taking, it is prompting. So it is prompting. So you cannot pass a. So you cannot pass. Okay, there is something you can do. So small w you give. Okay.
no, just give minus capital W and try.
It will prompt for the password, right?
So this password is it is asking for template one, right? So if we need to change to Postgres.
It is not template one. The password it is asking for, the user Postgres. Template one is a database name. It does not have the password.
Mhm.
Okay, so let it be
And
like
what is
that.
the
So
you pass H,
so
after that it is local IP of that server?
yeah, the local host IP. So if you want to do a TCP connection,
Okay.
okay, if you want to do a unique socket, so it should be just you can remove that. Okay, here one more important thing to note here is the test.sql may contain some what we say means insert or update statement also, right? Sometimes we do insert, update, delete statement also in that maintenance scripts generally we create. So if your script test.sql, if it is doing changes, so we expect it to do in a single transaction. So if one of the statement in the middle of the script fails, we want the entire script to be rolled back, right? So, we want to do all the statements within that .sql file to be a single transaction. If any one statement fails, we want all statements to be rolled back, all changes to be rolled back. So if you want that, you need to give -1. If you give -1, then the whole script is executed as a single transaction. And if any statement within that script fails, the whole transaction is rolled back. So this is an important thing to always include -1. So with that, okay. So there are a lot of other options as we have seen. So you can use this help. Okay, the command, DB name, file name. So if you use L, it will list available databases. So you can also use V to set the variables. Okay, you can use, if you want to know the version, it will show the version. So one is, if you use -1, that is single transaction, the entire file is executed as a single transaction. And, if anything happens in between, so it will just what we to do is, roll back everything. So that is a thing you must always include if you are executing the files, if you are executing the script files.
So it is suggested to include -1 or no?
It is suggested.
Okay, okay.
Okay, because if you have some statements which are doing changes, right? If in the middle of the script, if some statement fails, so what happens? The script is executed half, right, successfully, and then it has failed, right? So we don't want that. We want the entire script. In databases, any changes has to be done all or none. So then only we can maintain the consistency. So always include that single transaction -1.
Okay, got it. Thank you.
Especially if you are writing the .SQL scripts with insert, update, delete statements.
And one
So
more
if it
question,
is
what
just
is
a
this a
select, you
difference
don't need.
between this socket connection and the TCP connection? So which one we are going to use it in the projects mainly?
Okay, so maybe it depends on your project. Mostly TCP. So mostly TCP.
Okay.
So I'll show you the difference. Okay. So you have your Postgres here and your application server here. Let's say your application is Tomcat. It's a Java application. So Tomcat server is there. So now you can see these are two different machines, right? These are two different machines. So these are two different machines. Okay. Postgres and Tomcat. So always, the remote connections are possible with the TCP IP. So any database, the remote connections are possible with TCP IP. So other databases also uses UDP, but Postgres does not use UDP. In Postgres, the remote connections are always possible with the TCP IP. Okay, there is no question about it. Okay. So let us say, so you have, in some cases, you have a very large server. Okay, the same server is running Postgres and the same server is running Tomcat. So, in the same server, you are having your client and server, both of them are in the same Unix machine. So it is a Unix machine. Okay. So in such case, the connection can be, okay. So, the connection to the Tomcat to the Postgres database can be TCP, or it can also be unique socket. So here in this case, preferred is unique socket, and you can also do TCP. Got it? Hope you got right. So the unique socket connections are local. So, the unique socket connections are local only. So it is only local. It is not what we say means it is not remote. But whereas TCP can be local or remote. TCP can be local or remote. Hope you got your answer.
Yeah, got it.
Now, in our case, in our lab, our PSQL is on the same machine where Postgres is also running, right? Both client and server are on the same machine. So I can do TCP, I can do Unix socket. Okay. So, but if my PSQL is on a different machine and my Postgres server on a different machine, so then I don't have any choice but to do a TCP connection.
Okay.
Hope you are very clear about it.
Yeah, I got it. I got it.
Okay, so this is not just for Postgres, it is for any database which is running on Unix. Unix always provides this client server protocol Unix socket. So socket protocol we call it. So Unix provides, whether you want it or not, it will provide. Okay, so every application which is client server application which is written in Unix, so it supports both TCP and Unix. So this is how it is, but it is, this restriction is not there for Windows. In Windows, you have equivalent to Unix socket, but that is optional, use it or not use it. Okay. So hope everybody understood, right, about the protocols.
Yes, sir.
Okay. So you can also get that in HTML. Okay. So format, output format, in CSV format, you can get the output. So, so there is one thing called as expanded format also. I will tell you what that expanded format is. So host name, port number, username, and password. So these are the things we have. So, you can always see the options with the help option. Okay. Now let us connect to the Postgres. PSQL. Okay, some of the commands, like, I am using this. So some commands I'm starting with, backslash, right? So some commands, like if I am typing the query, so if I am typing the query, so I'm typing the query, I am not using that. Okay, for query, I am not using backslash. So this backslash are not Postgres SQL commands. They are meta commands specific to PSQL. In other clients, you don't find this, the meta commands. The meta commands are local or specific to PSQL. Okay, we call them as meta commands. And all the meta commands always starts with backslash. So if a command is starting with a backslash, that means it is a PSQL command. It works only in PSQL. It does not work in other Postgres clients like PG admin or anything. Okay, so that is what we have. So, one of the command is, backslash exclamation. So if you say backslash exclamation and then you can type any OS command, it will execute operating system command. So like this, clear the screen. Okay. So there are so many meta commands. So there are so many meta commands here. Like, so if you want a list of meta commands, just do a question mark here, backslash question mark. So it will list all the meta commands you got, all the commands PSQL supports. Okay. So all the meta commands are there. So including you have some if conditions also. If you are writing the .SQL files, right? So you can use if conditions in them. So you can include these meta commands in the .SQL files, the test.SQL I created, right? I only write SQL statements, but I can also include these meta commands as well. So that there is one group called as informational. This group is important. So, it is giving us informational, right now. So we are using this backslash D without anything, list tables, views, and sequences. Okay. So this yes, here, you have S, right? Capital S. So here it is giving capital S shows system objects. System objects means, so, the system tables. Plus means additional details. So if I say backslash D, only backslash D, it will tell me, it will give a list of user created tables. This T1 table is created by me, it is listing that. If I say backslash D and capital S, then it will list all the user created tables and system tables. So you can see user created tables and system tables. So you can identify our PG class. You can identify our PG database. So, there are a lot of system tables. So that is what, just by adding S, so you will get, the system tables. Nowadays, Windows is giving lot of news, right? Even the Mac, so, even the Android is not giving that many news. So it's a bit annoying.
What is that plus will give? Yes,
So I will
plus.
show you the plus. I didn't show the plus, right?
Correct.
So if I say backslash D, this information I will get, right? So if I add plus to it, I will get additional information. So earlier it was showing till owner, 4 columns it is showing. But now it is showing, a lot more methods. So lot more information about that particular table, including the size. So backslash L, it will show list of databases. If you say backslash L plus, it will show additional information apart from these. So 6 columns, it will also show more information, including it is showing the size of the database also.
Size table
Okay, this is the
space.
size of the database, right?
Correct.
So, table space in which this database is created. So it is showing additional information just by adding the plus. Again, remember, this is not the SQL Postgres command. This is the PSQL commands. So meta commands, in Oracle, you have some specific command to SQL plus and some, the Oracle commands, right? Queries. So these meta commands starts with, PSQL commands start with backslash. Okay. So you can also, backslash, we are giving, plus, it will give additional information. So you can also add yes. That means I want user table information. I want system table information. I want that plus information also, means extra information. So you can add that. Okay. So, you have this where we have that question mark. So always remember this question mark. So come to the information. So this is all we can extract. So, so if you want to know list of what we say table spaces only, so you have the DB. So if you want to list a domain, so a domain is a data type and, a constraint, check constraint. So all objects are there. Okay. So if you want to know about, indexes, DI is there. So, and you want to know the procedural languages, DL is there. So what procedural languages are supported? If you want to know materialized view, DM is there. So if you want to know the schemas, how many schemas the database has, DN is there. Okay. So if you want to know the sequences, you have that sequences. Tables means DT, only tables. Generally, if you use D, it will show tables, views, and sequences, table like objects. If you want only tables, you can use, okay, only DT. If you want to know all data, supported data types, so DT you have capital T. If you want to know only the users, DU is there. If you want to see views, DV is there. Extensions, so the DX is there. Extended statistics objects, if you want to list, DX is there. So event triggers, DY is there, list of databases, functions, so view definitions. So, that is all we have. So informational. So these are what we say means informational command. So, remember just one command, that is backslash question mark, wherever, whichever information you want to find. So you can just go into the informational block and you can find information, the respective command from here. Okay. So there is one thing called as, let's say select star. So from PG underscore database. So this is giving me a output like this. Sometimes, this output is messy. So what I can do is I can convert it to vertical output by enabling extended output. So backslash X is extended output, not expanded display. So if I give expanded display, select star from PG database. So after enabling the expanded display, if I run the same query, I will get vertical. Okay. So these are the details about our Postgres database. And these are the details about our template 1 database. And these are the details about our template 0 database. So vertical output. Select star from T1. So still the expanded output is on. So you will get, the vertical output only. We don't have any data in that. So let's insert something. Values. Okay, 2 rows I have inserted. So then you can see. Okay. So if I don't want expanded output, so I can just say expanded off and I can run my T1 query. So because the output is less wider, so I will get clear output here. So this looks better. If your output is, much wider than your screen width, so then you can use the expanded output. So you can toggle using X, this command. Okay. So you can also use the echo command here. Echo any message you can give. Okay. Any message. Actually, you don't need that, double quotes. Any message you can give that will be printed. So like, the operating system echo command. Okay. So also remember the meta commands does not have a semicolon. So meta commands does not require a semicolon. Okay. So, and here, so echo command hello, and what I'm going to do is, so I'm going to, we can also, so I'm saying set, okay, T, okay, T1, or, I am setting T as, PG class. So the table name I am giving. So now you do an echo, okay, colon T. So whenever you want to use the variable T, so you need to prefix it with colon. Like, in shell scripting, we will prefix the variable with a dollar, right? So here colon you need to do. So what I can do is select OID comma rel name. So from colon T you can give. Instead of typing the whole table name, right? So I can create some, okay, variables like that, and I can use it. So, you can see that. So it's working fine, right? Where, okay, rel name is equal to T1. So we will make it simple. Okay. So likewise, also you can use the variables.
This set command is available in this session only, or it will permanently added?
This session only. So if you log off and log in, that is gone. Actually, there is a file dot, PSQL RC file. So that is executed at the startup. If you can create a PSQL RC file, then you can put that in that file, so it will remain permanent. I'll show you, no problem. Okay, so you can unset also. Unset T. So variable can be unsetted. So after that, if you say so echo T, so it will simply say echo, so that only, because there is no variable called as T. Okay. So that is how you can use variables. For example, if you want to use these variables permanently, if you want to set, you can create a PSQL RC file in the home directory of the user. Exit here, and the home directory of the user is where like PGSQL, that is the home directory of the user. So what I am doing is I am creating a file nano.psql.rc. Like bash RC, we have PSQL RC. So in this file, I can set so PC is equal to PG underscore class. Okay, set uh, okay, PD is equal to PG underscore database. So let's say we start with these two. We will also put a message echo welcome to PSQL. Okay, echo. So use colon PC for PG underscore class. Echo use colon PG. Okay. So, I don't want to use colon here. So, or, just remove that, a lot of typing. So I want to write this. So exit. Okay. So whenever I log in into Postgres, so that file is executed. Whenever I log in into the Postgres, so that file is executed. Okay, it says welcome to PSQL, right? So I am saying, so I have to use PC, right? So PC. So now it is working fine, right? Okay, now you got it, how to do it. And the use of PSQL RC file. Okay. So that is how you can, make some of the variables permanent. So, but generally when you set them in the session, so they are only for the session, they will be, discarded once you exit that session. Okay. So that is about our PSQL. So, today we are supposed to complete. So today we are supposed to complete what we say means, PG admin 4 also. But however, tomorrow we will see. And these two topics have a lab exercises. So tomorrow I will give the lab exercise also. Okay, for these two topics, I will give a lab exercise tomorrow. Okay. And so from now onwards, every topic will have a lab exercise, so which you have to complete. Okay, now what we'll do is one last thing I will show before we call it a day. So we have another 5 minutes. So we will do that. I will show it and then we call it a day. So the thing is, we created the test.sql file, right? So once you are connected, okay, once you are connected to the Postgres, and now you want to execute the test.sql file, you can always use this \i command. So \i, you can use this file where live, so pgsql test.sql. So you give the file name, so this file gets executed in this session. Okay. So \i command you can always use from within the PSQL to execute any SQL script file. Okay. So that is it for today. So we have another 3 minutes. If you have any questions, you can go ahead and ask the questions. Uh, Otherwise, we can call it a day. So tomorrow I will give the practice lesson practice assignment for this topic PSQL, and also we have to install that PG admin for GUI web server we need to install. So we will complete that installation tomorrow before going to tomorrow's topic. So from today, one topic is pending PG admin 4. So any questions you can ask now. So we have another 3 minutes. So otherwise, if we don't have any questions, so we can close early today, 3 minutes early.
Hello.
Yes.
That shell script is supporting here. I mean, if we schedule any jobs like backup or anything, we can schedule it, right? In cron.
Yeah, we can schedule it in cron.
So
So
from
it's
there we
very
need to
simple.
run like.
If you want to schedule,
Hmm.
okay. So if you want to schedule that same tests.sql, so what you need to do is you can create a cron tab. You know how to create the cron jobs, right?
Hmm.
So you can create a cron tab. Let's say I want it to run on 15 minutes. Okay. Every 15 minutes on the 15th minute. Okay. So let us say, uh, you know, hours. So what you want for hours? Let's say 15. Let's say, so 23 hours. 23 hours means
11 p.m.
11 p.m. Okay. So I am saying like this 59. So that is, 59th minute. So 23rd hour, that is 11. So, it should run uh, day of months, first day of the month, second, third, fourth, all day of the months. Okay. So you can also give what we say means months, which months, all months. I want to run this script on all months. So whether it is what we say means January, February, March, whatever it is. Okay. So I can also give, the weekdays. So weekdays like, so if you want to give like Monday, Sunday, Monday to Friday, you can
Hmm.
give this.
Yeah, we can schedule. No, my question is that this is SQL file, right? Can we schedule like that KSH or SH file? I mean, it will execute.
Yeah, you can
That
also
is my question.
execute, right? So yeah, you can also execute. Here I am doing PSQL. So PSQL day, and then I am giving that, test.sql. So this is what I am giving here. Okay. So, what was your question?
That SH or KSH file, I mean, that is self script. Can we schedule
Also
like,
do,
because there I don't think we can
yeah,
pass
okay, I
PSQL.
got you. I got your problem. I understood
Hmm,
your
hmm, hmm.
requirement. Okay. So I'm doing this. You first create a test.sh. So, you want the same two commands, right?
Huh.
So these two statements you want from a shell file.
Yeah.
Okay. Nano test.sh. Okay. So I'm creating the test.sh. Okay, let's say we'll take this only one, this thing. We will write just one. Okay, one command we will write. So this is what. So, then what I'm doing is I'm saying here like this PSQL, the Postgres, okay, and then I am saying dash C. So then I am saying select star from, T1. Got it? Okay, I'm writing like this. Okay. So if you have more, you can also write more. Okay, now I have this test.sh, chmod plus x test.sh. Okay, so I can execute this test.sh, right? Okay, I can execute test.sh. So you also remember that PSQL RC is also getting executed. Okay, so so PSQL, now you can put this test.sh in the cron job. Got it?
Yeah, got it.
So you got it. You are very clear about it, right? So I will also put this test.sh. Okay. Got it. Any more questions? So I'm taking that as no questions. So we are done for today with one topic pending. So tomorrow we will complete that topic and tomorrow's topics also. So shall I stop the meeting for everyone?
Yes, sir.
Okay, see you guys tomorrow afternoon.
Thank
Okay,
you.
sir.